Right, good evening everyone, and welcome to this CIWEM Scottish branch webinar. My name's Alice Gent, the chair of the CIWEM Scottish branch, and this evening we're going to be hearing a presentation by Robbie Cowan, who is the survey lead at JBA Consulting. Just before we start, I've got a few notices in terms of general housekeeping and also some updates from other events that are taking place. All the webinars, including this one, are being recorded, so if you'd like to rewatch them or if you're not able to attend initially, they're all available on the CIWEM YouTube channel, so I'd encourage you to look at previous events there. If you do have any technical issues, please use the chat feature on Zoom to let us know, and myself or someone from the CIWEM HQ will assist to help resolve those issues. We'll be taking questions at the end. If you have any questions in the meantime, please use the Q&A function at the bottom, and we'll work through those at the end of the presentation. In terms of events and activities, CIWEM has switched to the digital world, and so as I said, all the presentations to date are available on the YouTube channel. In terms of dates coming up, on the 14th of April, we have the next Flood and Coast session, which is broadening innovative investment in FSERM. And in terms of other events, we've got one on the 25th of February, agent-based modelling of juvenile eel migration through estuaries, and on the 2nd of March, sustainable approaches to river engineering and management. There's also a new e-learning course on urban well-being, and further details can be found on the CIWEM website. But now over to Robbie. Thank you very much for the presentation this evening.
Thank you, Alice. My name is Robbie Cowan. I'm the Technical Director for Land Surveying at JBA Consulting. There was a bit of a blurb in the details that went out about this talk about me, so I won't bore you with that. You can read up on that. I'll just get straight into the talk. So this evening's journey, we'll start off just thinking about the end, where we want to go, what the survey's for. We'll go through various stages, including preparing the survey specification, the survey brief, what needs to be considered before we actually commence the fieldwork. Very brief look at the fieldwork, and then just a view of the deliverables and quality control for survey. So start about thinking about the end. It's important that whoever's commissioning the survey actually understands what they're wanting from the survey. Here we're generally talking about 1D and 1D, 2D modelling. When we talk about survey for river models, I mean, you know, it could be massive, it could be vast, and so therefore we've just not got time to cover lots of different aspects of it. So we'll concentrate on 1D and 1D2 modelling here. Things to think about. Is your site specific, or is it part of a national data set? Very two different propositions when it comes to survey. How is the end data going to be used? Are you very clear in actually what you want from your survey and how you're going to use it? It's very important that you understand what you want from your survey, otherwise how can you expect the surveyor to understand? Also, what other geospatial data is being used, both past and present? Is there historic data that you're going to combine your survey data with? And also, are you collecting other data alongside this survey? And also, can you quantify your requirements? So it shouldn't just be a case of, oh, I want 5 kilometres of survey rivered with cross sections. Can you actually quantify it? We'll start off with the site-specific project. The site specification, or the survey specification, and the survey brief are quite often combined in this document. And they're generally quite short. They're unique. They'll be derived from the modeller or by the modeller, and so therefore they'll have full ownership of it. The outputs will be simple, just really whatever the modeller needs. So you'll have the cross-section locations, you'll have cross-section drawings. Model files will probably only be the model file or the model format that you're actually wanting, and the site photographs. Critical aspects of survey for site-specific projects is the level datum. It needs to be consistent with the other data sets. quite often the site will already have a detailed topographical survey carried out. And so therefore it's vital that your survey for river models, for your flood risk assessment or whatever purpose you're using it for, that they tie in. And you can't just assume and say, well, they're both to ordnance datum. There's various ways that you can actually define ordnance datum, and I'll touch on that just in a minute. National data set is, the specification is a separate document and it's derived by the client, but it's to be used consistently across their business by many, many users. And they might have a slight different interpretation on the specification, but it is set, the specification is there to be used by all. It's also that you have alongside that the survey brief, and this is where the modeller can actually input specific requirements that they require for their project. The outputs are always comprehensive because it's going into a national data set, and so it's important that we have a standard set of outputs, and this standard approach encourages quality. So for a national data set, the normal specification is the Environment Agency specification, the national standard technical specification for surveying services. And it comes with 3 documents, the technical specification itself, a guidance for the users, which is very, very helpful, especially if you're not familiar with it, and the scope or the survey brief. And that's where the modeller can actually determine what they actually want. It also comes with a folder of templates, and this is to encourage consistency across all deliverables from all survey companies that are feeding into it. The current specification that the Environment Agency uses is version 4.01, dated June 2018. I understand that there is a draft version out for consultation just now. So I'm not sure when that's going to be released. There's a number of sections within the standard specification. Section 1, general requirements, and Section 2, survey control. These are applicable to all projects. And it's the survey control side that maybe modelers aren't as familiar with, and they maybe struggle a little bit on that side to actually determine what they want regarding survey control. Sections 4 and Sections 5 are probably much more, and they understand much more on the contents of that, the channel survey, what is actually required from the channel survey and building threshold survey. But as I say, I think there's about 9 or 10 different sections covering all aspects of surveying for the Environment Agency. I said that along with the survey specification goes the survey brief, and each of the national environmental agents in Scotland, Wales and England all make reference in their survey brief or their survey scope to the Environment Agency national survey specification. So if you're commissioning work for any of these bodies, then it's important that you don't just look at the survey brief, that you actually make yourself aware of what's in the survey specification as well. So we'll look at the survey specification and the survey brief and the different parts that make that up. We'll start off with the preparation, and the introduction. So, sorry to say it again, but you need to be clear as to what your requirements are. You shouldn't just have a centre line of a channel marked upstream and downstream and ask the surveyor to survey sections on that. You shouldn't even just say to them, well, we want them at a 100-metre interval, because the watercourse might change. There might be hydraulically important features along that length. And although, and again, I'll touch on this in the future, you know, experienced surveyors for river models would appreciate these. You still have to give them a bit more than that. You have to have reviewed it yourself. and come up with what the requirements are. You need to check existing survey data, both control and detail. If it's a national data set, there might be existing survey, but it might be quite old. And so therefore, is it appropriate for your needs? You need to check the origins of the height datum. And here I've got the OSBM, which is Ordnance Survey Benchmarks. These are obsolete, so it's very unlikely that your height datum of existing data will be actually OSBM. OSGM 91 was when GPS first was used as a referencing tool in surveying, and it was preceded by OSGM 02, and then currently we use OSGM 15. These terms are the transformation on how you get GPS levels to your national datum, OS datum. So OSGM 15 is the way that GPS transfers heights since about August 2016. So if you've got data that precedes that, is before that, sorry, then you've got to consider the difference between the two datums, or the two models, GEOI models 02 and 15. And interestingly enough, the Ordnance Survey have a page where you can check what the difference is, which is quite helpful. And there's also a report produced, and I'll just show you the overview of that in the next slide. You also need to consider what other geospatial data you're proposing to use. So you might have LiDAR that you're going to be combining your survey data with. So if you are combining various historic survey data or new geospatial data sets, it's important you carry out some sort of validation process to make sure that all these surveys tie together. It's pointless waiting until the end and then finding that you've got 15, 20, 25 centimeters difference in height datum between your data sets. You need to understand that very early on in your project, and so therefore you need to consider a validation process. So here's the overview of the difference between OSGM 02 and OSGM 15. On the left-hand side, you can see the outline of the UK. The colour, anything between yellow and kind of green, or certainly green, means that there's only a difference of about 25 millimetres between the two transformations, which in all honesty is minimal, especially when it comes to surveying for river models. However, for us that are located in Scotland, you can see that we've got maybe a bit more of a challenge, and we need a bit more of an understanding to what's going on here. The Outer Hebrides, at the north end, there's a difference positive of 30 centimetres, but by the bottom of the Outer Hebrides, you've got a difference of negative 30 centimetres. So you've got a range of 60 centimetres between how the transformation models calculated your OS datum when using GPS. This could have a huge implication on the data that you're deriving from the survey. And it has a huge implication potentially if you're combining historic survey data with your new survey data. So it's very important you understand this. On the right hand side is the OS update tool. You simply put in, you don't have to do any survey with this actually out in the field. You can simply put in the coordinates of your site, arbitrary coordinates within your site, and then a height. You could put 10 meters, for instance, and then you could do a check to the 15 and see what the height changes to, and that gives you the separation of the difference between the two models, GEOI models. Very helpful to have. Carrying on with the survey brief, terms and conditions. Obviously that's important to have within the document. You're specifying whether you're using your own terms and conditions or whether you're using client ones or whatever, but it's important to include those. An introduction and a background to the project as well, and the names and objectives of the survey data. the more you can tell or let the surveyor know about what the data is going to be used for, the more that, in a sense, they can help you. They're going to be your eyes when they're actually carrying out the survey. And so therefore, if they understand what your aims and objectives are, then they're more likely to be able to feed back to you anything that see that can maybe influence this actually in the field. The survey scope itself needs to be clearly written and summarise the services that you require. So here's a couple of examples, or an example actually, it's the same document I've taken it from. So you can see here 2 different water courses. The modeller has clearly specified how many sections they want. Straight up front, a total of 33 sections. On the Morton Brook, a total of 58 sections. And so therefore the surveyor knows at tender stage exactly how many sections are needed as part of this commission. Then they've broken them down to open channels, culvert, bridges, structures, and gauging stations, and other features as well. So this is really good. It's very clear. Straight away, the surveyor understands what's being required from the survey. This project was maybe a couple of years ago, and you can see that obviously on the left-hand side, the Eshton Beg, it was probably going to be combined with historic data, and so therefore the modeller decided that they wanted the height datum to be OSGM 02, so that the 2 sets of data combined seamlessly together. Whereas the one on the right-hand side, it was maybe a new survey, and it was to do OSGM 15. There's a length of water course in each of, top of bank in each of them as well. And again, the modeller has specified very clearly actually what's required. Approximately 1.3 kilometres of water course required on both banks, again specifying on both banks so that it's very clear actually what's required. And then they include some health and safety as well, of known issues that they have. The technical requirement of the survey scope, survey control, well, you might already have survey control in your area, and so therefore you might just want to check it. Or there might not be any survey control, and so therefore you want the surveyor to establish new control. Or for larger projects, it could be both. It could be a case of establishing new control, but also checking onto some existing ones. Your reference system, Ordnance Survey, National Grid, and probably nowadays OSTN 15 and OSGM 15. The cross-section naming is quite important, specifying where you want the zero chainage to start. Is it a confluence? Is it part of existing survey data? So therefore you might want it to be tied into that existing survey data. And the format as well. Is there a specific naming format that you want it to follow? This is quite important because it's very difficult for the surveyor to change all this at the end, so they could deliver you all these sets of lovely deliverables, and then all of a sudden if you said, oh, I wanted the zero chainage to start at such and such a point, it would basically mean that they would have to reprocess everything. It would be very time consuming. On the channel cross-section and floodplain sections, specify whether you want hard or soft or both, and also specify the extent. It's normal for a channel cross-section to go 10 metres back from the channel, from the top of the bank. If you're wanting it to extend further than that, then again, you need to be very clear about that. The hydraulic structures, including bridges and culverts, well, the critical levels, the flow paths, you need to describe what you actually want. So the difference with regards a site-specific project and a national dataset project is that a lot of these things, these technical requirements, are already included in the survey specification, the Environment Agency survey specification. And the guidance note that's within that suite of documents guides you to where you actually need to add more detail or your own specific detail. If you're doing a survey specification / survey brief for a standalone job, then you need to consider these things and make sure that they're in the document that you're preparing. Top of bank survey, it's not a standard piece of survey, so therefore you have to specify it if you're looking for it. And you probably need to go as far as saying, well, do you just need the crest, or do you want the crest and the toe? Do you want the toe just on the wet side, or do you want it on the wet side and the dry side? You need to be specific. You need to understand what survey data you're looking for in the end, and you need to be specific about it. Other surveys could include gauging locations, outfalls, etc. Again, if you're aware of these, exists, for instance, a gauging location, let the surveyor know, have it in the specification so they understand that needs to be collected. You need to state the accuracy that you want the survey data, but make it realistic. I can't just say to you, oh, well, all levels should be accurate to plus or minus whatever. It depends what you're surveying. For instance, soft bank, soft detail, realistically, plus or minus 50 millimeters, should be reasonable. For a hard standing, maybe plus or minus 20 millimeters, for structures and things like that. If you're actually looking specifically at a gauging station and you're maybe wanting as part of a monitoring survey for the gauging station, then you'll be talking about millimeters. But if you just said straight away, well, you want all your survey data to plus or minus 5 millimeters, for instance, that would add tremendous cost onto your project when it's not needed. And the problem you'd end up getting is that, if you went to 2 or 3 survey companies, some of them might just dismiss it, that accuracy, and say, well, for a grass bank, top of embankment, you don't want 5 millimeters. You can't use that accuracy, 5 millimeters. So I'll just discard it and I'll do what I think's right. So as I say, it's important that you make it realistic, the accuracy. The kind of last thing in the survey scope is the deliverables. You need to state clearly what deliverable formats you want. Survey report should be comprehensive for a national data set. It needs to go with the data, and it needs to explain the survey, how it's been done, how things have tied together, how you've incorporated cross-checking and made the results robust. You need to include your permanent stations as well and your calibration certificates. And then there's a number of the deliverables, standard deliverables that are contained with the Environment Agency specification, survey specification. Location plan, cross sections, long sections, model files, probably in all those formats, so they have the flexibility of multiple users or in the future. Photographs, GIS, and another survey like tops of banks. Big difference with site-specific requirement is that it's only you, the modeler, that's going to be using that data. It's not going to go into some data archive. So therefore, you potentially would cut right down the deliverables that you're requiring. I would still ask for a basic survey report because that again tells you the user how things are tied together. If there's an existing topographical survey, you want confirmation that it's been tied into that. Location plan, so you can see where the sections have been taken, cross sections, model files, just a single format, whatever model software you're going to be using, and obviously the photographs. So it's cut down quite dramatically, that. The mapping is very important, as well as having it written down, what's actually required. The surveyor needs to see a graphical representation of it. And it needs to be as clear as possible and as precise as possible. So within your GIS table, instead of just having cross-section, if you had upstream face of road bridge, downstream face of road bridge, then this gives much more information to the modeler to actually understand what you're wanting surveyed. It's good to include these tables in Excel format and PDF format because they're basically quite uniform to actually use. So here's an example of some mapping. It's quite a small area, but I just felt that this kind of demonstrated quite well. We've got a couple of culverts there that we can see straight away, the black structures. The downstream end that's coming out at the sea, downstream tidal face of culvert. So again, we understand it's going into the sea, and it's a straight line, or to be shown as a straight line. But then the second culvert actually has a kink in it, a bend in it. So the surveyor understands for the centre line, for the chainages, what line they should actually be following. And then we have a description of the cross sections: upstream face, downstream face, open ones, and reservoir spillways. So it's all very clear to the surveyor what's actually needing to be surveyed here. The project-specific associated information. This is something that you personally might not feel much value in, but the surveyor, it's good to pass on as much information to the surveyor as possible, right from the start, right from the tendering stage. So health and safety. Are there site-specific hazards that the surveyor should be aware of? It's a case of, well, if you already know that you know, there's some health and safety problem, it might be access into the channel, for instance, because it might be a closed channel with vertical walls. So it's good for you to be as descriptive as possible. Landowner and access, any known difficulties there, it would be good for the surveyor to know about that. And it would be good for you to actually start thinking about that right from the start, because that can have further implications down the line. Environmental considerations, invasive species, giant hogweed, for instance, is that present on site? You know, the surveyor should be aware of it as early as possible. And also, what kind of information are you going to provide them? Are you going to provide them with, you know, some historic survey data to check? Are you going to provide them with OS background mapping, etc.? So there's a quick summary of the survey brief / survey specification. Do you understand what you want from the survey? Can you quantify it? We go to the survey scope, which details what is required in the survey and the deliverables. We have the mapping to go along with that. And then finally, the other project-specific associated information, the health and safety, the land access, and ownership issues that are known about. So before the fieldwork begins, we assume that you've maybe commissioned the surveyor by now, although some of these points that are raised, you know, could be included in the tender stage as well. Health and safety risks, programme risks, technical risks, and reputational. So health and safety is paramount to a successful project. Working in, on, or near water has potential dangers. Everyone has a role to play, right from the company that's providing guidance and appropriate training, through to the client and the modeller, who must highlight any known dangers as early as possible. You could then go to the project manager or the lead surveyor of the actual survey company, and they have to propose the safe method of working. And then each member of the survey team must follow the guidance and the approved systems when they're actually out in the field. And all of those people shouldn't be afraid to challenge something. So therefore, you as your project manager or your modeller, if you're not happy with what the surveyor's proposing, then you challenge it. Similarly, the other way around, if the surveyor and the lead surveyor or the survey manager isn't happy with what the client is actually asking, then they should challenge it. A safe way is the right way. And there'll be two main documents that we'll use to manage the health and safety: site-specific risk assessment and the safe system of work. Safe system of work comes in all shapes and sizes, some longer, some shorter, but basically they're identifying the key risks and they're scoring them and they're putting mitigation in place to try to minimise that risk. Task with most serious consequences. When we're talking about survey for river models, then the two ones that really stand out are the driving. Everyone has to drive to site and drive home again, and the working on, in or near water. Key hazards. You're driving, fatigue, duration, type of road, time of year, road condition, poor driving habits, things like that. And you need to see that the surveyor has put in place certain things that they think will minimise that. Working in on or near water, well, deep water, strength of flow, etc. Again, all quite obvious, but the surveyor needs to put in place things that are actually going to manage that risk. Now, interestingly enough, driving, you would never expect somebody to get into a car and drive to site without, one, having a driving licence, and two, being insured. But I just wonder how many people ask someone to go and work in a river or on a river without any sort of training, formal training. Ensure all staff have sufficient training. There's water awareness suitable for working near water. Okay, and that's generally a one-day course. You wouldn't anticipate the individual to fall in, basically, but the water awareness will give them an understanding of how to use their life jacket, how to check for the life jacket, and what the hazards are when working near water. Swift water flood first responder, deaf from module 2, is suitable for working in water, and that's a two-day course. The second day involves you getting in the water, getting wet, getting washed away down the river, and being able to self-rescue or rescue a colleague. And it's hands-on, practical work that is very, very important for anyone that is actually working in water. We also have the Royal Yacht Association competency courses for operating a boat. That's power boat, level 2, I think it is. And I would certainly recommend a first aid course as well for each member of the team. It's pointless just one member of the team having first aid trained. If it's them that's the casualty, then what's the other person supposed to do? Ensure all service staff have the experience and confidence to carry out each set task. That's vital. The safe system of work was the second piece of documentation, and it details the sequences of activities and the procedure for controlling specific tasks. And it will identify the tools, the equipment, and most importantly, the PPE, and also the competency of the users in the PPE. So therefore, if you're proposing a life jacket as part of your PPE, how do you show that the user is competent? Well, can I suggest that if they've been on a water awareness course, or even better, the swift water training, then that's part of the training that they'll have been given as part of that course. Safe system of work is not just about how you carry out the work, but it's also what happens if there's an emergency. What happens if the site conditions changes? What happens if the water level starts rising? Well, the safe system of work will say you come off site, you reassess the risks because they've changed, and you make a decision on whether it's safe to continue. What happens if something goes wrong? What happens if somebody is in the water, loses their footing and starts going downstream? You have to have an emergency, a safety plan, rescue plan in place, and that will be in the safe system of work. Ensuring all survey staff are sufficiently trained will again go part of that way, because that's part of your training in those courses. Programme risk, access, I mentioned that earlier, and I can't highlight how important it is. It needs to be considered very early on in the project. Is the landowner potential problems to actually access the river, the survey area? Weather and high water levels, obviously we don't really know that until a few days before it actually happens, but it's something that we need to be aware of. Gauging stations can be checked online to see what the current levels are. poor communications, we have regular progress reports, maybe every week, then we understand how the programme is being kept on track. And failure to capture all the data, well, this is maybe something that isn't within the programme up to the surveyor issuing the data, but it can then affect your programme leading forward, because if you haven't collected all the data, then it's going to need to resurvey. Some technical issues that the surveyor and yourself have to be aware of is calibration and incorrect configuration of equipment. This will result in potential errors within the equipment, and it's important that survey methods should incorporate self-checking, and so therefore it makes the results much more robust. And I mentioned about the datums and the control earlier on, about the differences between OSG and 2 and 15, etc. So if you use experienced river surveyors, a lot of these potential errors can be eliminated. And the same with reputational risks. Using experienced surveyors, river surveyors can eliminate many of the potential risks, because they are aware of these. Emissions in drawings, missing flow routes. If you talk about a flow route to a non-river surveyor, they will just look at you blankly. But if you talk about flow routes and overtopping, etc., then an experienced river surveyor will know exactly what you're talking about, and they'll be trying to identify these things for you in the field when they're carrying out the survey. A very quick brief look at the field work. At the end of the day, every site is different, and so therefore you shouldn't be specifying to the surveyor how they do the work. What you should be specifying and what equipment they should be using. You should be specifying to the surveyor what you want, what data do you want, and you should be leaving it up to the surveyor to capture it in the proper means. So for instance, here we have a remote control survey boat. It might be weightable, I don't know, but you shouldn't be specifying the method of capture. You should only be specifying what data you want. The standard piece of survey equipment that we have from our surveyor uses nowadays, in the middle is GPS, Global Positioning System, which that's the old term, because GPS is only the American system. We actually use, the surveyors use GNSS now, which is a combination of multiple systems. The American system, the Russian GLONASS system, potentially Galileo, the European system when it's up and running. On the left-hand side, we have a total station, which is part of the mainstay of the survey kit, and on the right-hand side, a digital level. So that's the standard pieces of equipment that surveyor will use nowadays. But they do have many, many tools in the box. Technology has just gone crazy in the last 5–10 years when it comes to survey. So here we have a 3D laser scanner, and we've scanned the spillway of our dam, and we've basically produced point clouds and a surface for computational fluid measurements. So it's much more complicated than just a 1D or 2D river survey. But as I say, this is where you shouldn't be specifying to the surveyor what they need. How they do the survey. You should just be specifying what your outputs are. I'll quickly go through this. This is a cross-section, and I mean, it's obvious, but I just thought I'd stick a couple of slides in. The cross-sections always look downstream. They should always be at right angles to the flow, and they should define the positions of the main channel. Yes, very standard for the modeler, but it's just a case of the surveyor should understand these. The river surveyor should understand these and will understand these. How much detail do you put on the cross-section? Well, as you can see here within the channel, we have a lot more points that are a lot closer together, because that's the important part. That's where the water will always flow, and that's what you need to calculate the capacity of, in a sense. Once we get out onto the floodplain, then the point intervals get wider. So here's just an example, cross-section detail. So we've got a left bank, a right bank. You can see on one side goes up a steep banking, on the other side it flattens out. And this is just the representation we would have. You can see that we don't necessarily need to go this far up on the left bank because it goes to high ground, whilst on the right bank is where the water's going to flow. So therefore that's what the surveyor has to be keeping in mind when they're carrying out the survey. Another channel, and again it goes to high ground on one side and the low ground on the other, and so therefore there's not really the need to go as high up on the right hand side as they have. Cross-section structures, these are vital to the model, potential restrictions, and they must be surveyed accurately. So the upstream face is the most important. The downstream face can be copied if need be, but the opening area and the overflow points are the important things, including the parapet and the railings. The springer, soffit, invert, bank levels on both faces would be surveyed and included in the cross-section. The tunnel length and the skew angle will be measured in the processing stage with the data that's been collected on site. And the natural shape of the channel is also important. So here, as an example, we have a footbridge, but you can see the natural shape of the channel has been surveyed correctly. The surveyor's not taking it up to the deck level at the end of the bridge because that's not how the natural shape of the channel lies. It actually, and the other thing important here is that the walkway, the deck level, actually ties in to the ground level, and so therefore the modeller can see that what the overtopping is, or where the overtopping would be. So just a quick example, good and bad. Very quickly you would see that and you think, oh, it looks, it looks quite good. I like the brick effect on the facade, but it doesn't go far enough up, basically. It stops short of the deck level. It needs to extend to the deck level so the modeller understands. Also, the pillars and the abutments, there's not a point being taken, so there's not a chainage marker at those points, which is important, so that the modeller can quickly and easily understand the width of the structures, the openings. So not as good as it first appears. Here, finally, we have the location plan, and what we've done here is we've actually incorporated the top of bank levels and the floodplain levels on it as well, just so that the modeller can get a really good overview of all the survey data that's been collected in this project. Photographs are vital, and it's a case of that there should be enough photographs to clearly show the cross-section. They can be used by the surveyor for checking the survey data, and they're used by the modeller as well. Last bit is the quality control. So we've got all the survey data in. The modeller should use a validation spreadsheet to just have a system in place on the checks. Kind of checks that they're going to do, the structure length, is it included? Are the soffit and invert levels labelled? Is there skew on the structure? Has it been identified? Things like this. Cross-section levels equal long section levels. So double check, cross-check data that you've been provided with and make sure that they tie in together. But have a structure basically here so that it's part of your audit process. So the potential survey issues. A couple of slides here. Locations missed causing delays, i.e. gauge boards or discharge pipes or weirs. Well, the solution, a clear survey brief. Pass on as much information to the surveyor as you can and use experienced river surveyors, and they are much more likely to actually appreciate what information needs to be collected. The same with insufficient detail taken along. Use along cross sections. Use experienced river surveyors. Incorrect survey locations. be clear in the survey brief. Sometimes it's okay to move an open channel cross-section, and the surveyor might move it for 5 or 10 metres for a particular reason, but sometimes it's not. If it's a narrowing or a changing gradient that you've identified and you want it specifically at that point, then maybe make that clear in the actual survey brief. Joining of survey data together, as I say, this was always the best to be pre-planned and included in some sort of validation before you start on site. Late delivery of data, well, if you have regular progress reports, then you're going to keep on top of that. Changes in the specification that are not implemented, written communication there just to confirm exactly what the change has been. The model data doesn't load, well, use experienced river surveyors that have done hundreds of similar jobs in the past and have proven systems that work. And if not, then ask for some data. If you're using someone for the first time, ask for some data before they start the project, just so that you can test it. Same with the data named in the formatted. Ask them, if it's the first time you've used them, ask them for some data, and then you can review that before they actually start. So that's me. Thank you very much for your time. I think somebody is maybe going to let me know if there's any questions. Alice?
Yeah, there's a few come in. So first of all, there's a question about the variable level of accuracy applied further to the interpretation of scope and guidance. And the person said, I imagine there are accepted levels dependent for purpose. How does one reference experience in the contract? Is there a certification route or is there a chartership route?
I'm not sure what you mean about the second part there. The first part, the accuracy.
So I think that's two separate questions. Sorry.
Yes,
sorry.
Yes. Start with the accuracy. As I say, it's experience really. You know, and from my experience of working with modelers, and if you look at the Environment Agency specification, survey specification, it'll give you guidance as well on actually what the expected accuracy should be. And I would say plus or minus 50 mil for vertical, for soft surfaces, plus or minus 20 mil for hard surfaces and structures. And as I say, that's the two main categories. Sometimes you might want further higher detail, or sorry, higher accuracy for specific purposes, like for monitoring of gauging stations, etc. What was the second part, sorry?
How do you reference experience in the contract? So do you make a requirement for certification levels and things?
Basically your CV. I would never say that you have to have a qualification, but certainly experience. You know, so if you're asking for the specific staff that are actually going to be used in the project, a brief, you know, pen portrait on them. It's always good to see formal training and professional qualifications. You know, it's always good. Professional qualifications give you CPD, give you continuous learning, and it gives you confidence that, you know, that people are keeping up to date with the latest standards.
Brilliant, thank you. Next question is, what are the required permits or licenses which should be secured from concerned parties before starting survey activities?
Concerned parties? Do you mean landowners?
Interested parties, I think, yes, potentially, yes. I imagine.
Yeah. Well, again, the client is probably the most important person here to be liaising. If it's a national body, then this organisation will have local representatives in the area, working in the area, and they'll be working with landowners, you know, previously. So therefore, it is a case of it's much better to have that approach. If it's a site-specific project, then the chances is you're doing the survey for the landowner themselves because they want to develop on it, and so therefore, you know, you would get land access, you know, through them. But it is the client, I would say, is probably the most helpful to secure land access.
Thank you. The next one is on your advice on drone survey, because they're becoming more frequent in coastal survey and changes in beach levels.
Yes, yeah. I could have had a whole talk on drone surveys, and I was tempted just to put a slide in, but I would have gone even on further than I already have. Drone surveys used in the right hands have potential, huge potential, without a doubt. But on the other hand, and it's the same with a lot of survey equipment, if it's used in the wrong hands, then you can get rubbish out. And there's maybe wrong perceptions regarding drone surveys that what it will actually give you. The most important thing, I think, for a drone survey, especially, there's two different types of drone survey. There's the traditional photogrammetric drone survey where you're taking images, and there's a mini LiDAR where you're kind of using, LiDAR technology. Talking about the photogrammetry side, it's important to remember that it doesn't penetrate the vegetation. So the question came on the coastal aspect. And yes, I think, if you've got hard rocks, you've got hard standing, drone surveys have potential, huge potential in that hazardous area of a coastal area, to collect survey data. But if you're talking about going along in a grass embankment where the vegetation is up to your waist, then you're not going to get accurate survey data there using a drone survey. That's just what it comes down to. So it has to be used in the right places.
Brilliant, thank you. Next question, what advice do you have to a modeller that has inherited a survey they don't have much confidence in and they have the opportunity to question the survey deliverables?
Have the confidence to question them is what I would say. It is a case of if you're confident enough to run the model, you're confident enough to basically know what you want. The only thing that I would suggest is that you make sure that whatever you're going back to the surveyor with regards you don't think has been done, did you include it in the specification? Were you clear in the specification, or were you a bit woolly? And it's not until you've got the data that you've actually realised, oh, I should have got this or that done. But as I say, it's a case of, I strongly believe in surveying for river models is about a partnership. It's about the modeller and it's about the surveyor working together and having a level of trust and a level of understanding. And that just doesn't come with one project. Survey for river models is about a journey, and it's about building up trust, between both parties. And that's the best way forward, I would suggest.
Thank you. Where we're talking about checking or truthing LiDAR and topo survey, it's a question, why only focus on the hard areas for comparison? Because
the hard areas are where you're going to get, you're going to minimize the noise. If you try to validate a grass field, for instance, then the vegetation affects the quality of the data. If you've got a nice flat car park, then really you should have through both methods of survey, you should have repeatability. Somebody should be able to go to the same point and resurvey it and get the same answer from multiple sources. As I say, a grass bank, a vegetated area, soft detail, you've got too much other variables coming into the equation.
Thank you. And just in relation to soft services, there's a question. So is there an expectation of accuracy at the 4-degree temperature rise in climate change modelling if you are serving soft levels?
I'm sorry, 4 degrees climate change rise, I don't know how that affects surveying. Sorry.
There's no further information on that, I'm afraid. I'm not sure if it's to do with the change in, possibly changing coastal services and things, if it was done at a certain time of year, whether you'd expect to have to do a survey again if the environment's changed, possibly. I'm not sure if the
I don't know. Survey is all about repeatability. And the whole basis of surveying is that you have a reference network, and it's stable, and basically you can carry out repeated measurements over a number of years that will be consistent. Now, unfortunately, that hasn't been the case with when we changed from OSGM 02 to OSGM 15. You saw particularly out in the Outer Hebrides how the model has been recalibrated, and it's resulted in quite dramatic changes between the two transformations. But moving forward, nowadays, I would expect that somebody, doesn't matter about climate change or anything like that, you should have repeatability. You should be able to go back to the same point, and you should be able to survey it to the accuracy of, within the accuracy of the method of how you've actually derived it, basically. I'm not sure I've really answered that one very well, I'm sorry. If I haven't answered that, I'm quite happy for somebody to contact me, basically, if they want more explanation out with this forum, because I'm afraid I've probably not picked that up correctly, I'm sorry.
No, thank you. Yes, if the person who raised that question, if you do want to follow up, please do let us know. Thank you.
Yes.
I'll just take a couple more because I appreciate there's a lot of questions coming in, but the next one is about when doing in-channel surveying, how's the difference between silt and mud and bed levels and hard bed levels determined? How do we distinguish between the two?
Quite difficult, actually. I mean, it's, you know, at the end of the day, I wouldn't say it's scientific. It is a case of you have a pole and you have a small thing on the bottom, and it's just how far you push into it. So it's not an exact science. You know, we're not grading it exactly to a specific Newton watch pressure, I don't know. You know, so obviously the top is much easier to survey, but how deep is the silt? Well, generally it's a case of how far in you can push your pole.
Thank you. Next question is, if undertaking modelling work for a watercourse in England where the composite LiDAR is older, e.g. pre-OSGM 15, is it best to capture the channel survey using OSBM 02 to align more closely with the datum the LiDAR was captured in, or OSGM 15, considering the differences between the datums?
In England, the accuracy of LiDAR is 10 centimetres, plus or minus 10 centimetres. And the difference between the 02 and the 15 transformations in England is 2 centimetres. So therefore, to me, the accuracy of the LiDAR is a lot less anyway. And so therefore, I would just merge them together. Yeah, I would suggest you've got more of a problem in Scotland, where if you've got a difference between the two datums of 10, 15, 20 centimetres, then all of a sudden that is going to have a fundamental effect on how you can join data sets together. But really in England, as I say, the difference between the two transformations is really minimal. So.
Thank you. There's a question, I'll just take a few more because I know there's a lot coming in, but is there a public access data available on river surveys in the detail you're describing? And just to get an understanding about the I suppose the ownership access.
Public access, no. At the end of the day, the client basically pays for it. So it would be up to the Environment Agency, it would be up to SEPA, it would be up to Natural Resources Wales, whether they want to make that data available as an open source. But it isn't, because at the end of the day, they've bought it, you know, they've paid for it, so they own it.
Sure, thank you. Is there any survey equipment or post-processing methodology for silt depth surveys?
I'm not very well. When you've got silt, if you've got, for instance, silt in a reservoir or something like that, then there's sub-bottom profilers that you can use that would actually determine the thicknesses of the silt, quite accurately. If you're just talking about it in a river environment, again, it's one of these things. And I said when I first slide about the about the field work. Every job's different, every site is different. So, you know, the potential method or how you would actually fulfill that would actually depend on your particular problem or what data you're looking out for. As I say, you can't put a sub-bottom profiler in a small river like I'm showing there, you know, and you know, so therefore you would be using a pole, you know, to get the depth. So it depends where the environment is that you're talking about, depending what methods you could actually use.
Sure. And a question in terms of the survey scope, what is the most common thing you find that's overlooked by a client, or the things that the surveyors always find missed off their requirements?
I don't think there's one thing in particular. I would say the most important thing for the surveyor is to have the survey requirements quantified. We want 200 cross sections. We want 20 cross sections. You know, it might surprise some people, but I do still get just a centre line and say I want survey every 200 metres in rural areas, every 100 metres in urban areas, but it might go down to 50 metres in urban areas. And so therefore, you know, it's a case of, do you want me just to do it every 200 metres? But what happens if it changes? You know, what happens if the structures? Am I supposed to go through all the imagery and pick out all the structures and include that in my survey? You know, so as I say, the clearer that a survey, the clearer that a modeller can be to actually what quantities are actually needed, I would say that's the most critical thing. Along with the mapping then, so we can see where the proposed sections are.
Sure, thank you. Now I'll just do a final question. Have the results of survey changed depending on the seasons? Is there a specific time of the year where you'd recommend undertaking survey?
As I said earlier, the whole principle of surveying is that you should be able to go back to the same point and resurvey it in the future and get the same coordinate, the same X, Y, and Z. And that doesn't matter what season it is. You know, this should still be that reliability of repeatability. The one thing for surveyor is that as the seasons change, the challenges change. So especially for river surveys, in the winter, we've got no leaves, no vegetation, so we can see the banks quite clearly. We can see through the trees because there's no leaves, but the water level is generally higher. And then in the summer, it reverses. Basically, the water level goes down, which makes it much safer, but the banks are full of vegetation and you can't see anything, and you basically struggle to actually, you know, get into the to get lines of sight from your instrumentation. So there's always a challenge for surveyors, always a challenge for them to overcome in the field.
Brilliant, thank you, Robbie. There are a few more questions that are coming in. So are you happy for
yes, yeah,
for people
I'm
to
happy.
email?
Yes, or yeah, I mean, I'm happy to sit and answer them if you've got time, Alice.
I've got time. Yes, I just know it's after doing an hour's presentation. It's
no, just carry on anyway. I was kind of yeah.
That's fine.
Try and cover as many as possible.
Yeah, that's fine. Are there also flow rate measurements for watercourses with flow sensors, brackets for other physical characteristics such as velocity and sediment movement?
A surveyor, a traditional, even a river surveyor, wouldn't generally do that. I would say that is a little bit specialist. There are EDCPs which basically have they profile the bottom, but they also profile the velocities going across the channel. But it's more the likes of the Environment Agency that would actually do that as part of their hydrology for you know, a gauging station, for instance. It's not something that a river or a land surveyor would really be involved in. It's not something I've got experience with.
Sure. In terms of using, there's a question saying, are you using a 1D, 2D model? And if so, have you got a preferred model?
I don't have a model. It's the bottom line. I do the survey for the modeller, and it's the modeller that has to decide what type of model they're running.
as a statement more about the difficulty in assessing the Manning's coefficient for sections of the watercourse. I'm assuming that's a question in relation to whether this can be something that the surveyor can specify.
The surveyor, traditionally the surveyor wouldn't. Traditionally, that's what the photographs were for, and the modeler would basically, when they were building their model, they would look at that. Some of the soft outputs that we can produce, HECRAS and ICES, or Flood Modeler, it has a basic Manning's in it from the channel, in the channel or out with the channel, but it is just, it's generic. The Environment Agency have got their own specification, survey format called EACSD, and it actually incorporates much more about the surfaces across the cross section, and so potentially that could be used in the future for calculating Manning's in a more automated process.
Thank you. The next one is, with the advent of big data and surveying equipment advances like the ARC boat with Doppler radar, bathymetry and velocity sensors, do you see hydraulic modelling and surveying going down the cloud point route?
I was told very early on in my days at JBA that for 1D and 2D, or for 1D modelling, the best models are the simplest models. And so therefore it's a case of you only survey what's critical that will actually affect the model. So therefore on one side, I would say that we still have to appreciate that sometimes we just need to collect basic information because that's what the model needs. It just needs basic information. But on the other hand, yes, I do appreciate that today's technology can collect millions of points a second. You know, a 3D laser scan, terrestrial laser scan, drone survey, you know, can produce point clouds. And yes, you know, multi scan bathymetry, you know. So yeah, we can produce point clouds, but the user has to be able to use them. You know, and I am experiencing that on a regular basis where we have obtained point cloud data, but the engineer or the analyst just can't use it. It's too massive, and they want lines, they want break lines, they want a surface, you know, an accurate surface that represents the terrain, the topography, and the point cloud is just too dense for them. So, but I do appreciate that, you know, it has its uses without a doubt. And the advantage of a point cloud is that you collect all the data in one go. And then if you need to revisit that site or that project for any reason in the future, you don't probably have to go back out to resurvey things. You can just go back to your point cloud and abstract the data that you need.
And just following on from sort of different types of survey, for drone surveys, in the same way that you would need to obtain landowner permission, would you need to notify the landowners or tenants of any physical surveys in terms of drone surveys if they're on the flight path?
The first thing is that you need to be licensed to operate your drone. And so therefore, again, every site is different here. There's, you know, buffers around airports, you know, that you're not allowed to fly. There's set distances away from people and crowded areas that you're not allowed to fly. And so therefore, if you're proposing to carry out a drone survey, then you need to make sure that your operator is fully qualified, and they would advise you on the situation for that particular site.
Sure, thank you. Several comments coming in saying how a very interesting talk. A comment with regards to the EA specification version 5, which you mentioned, it's a comment saying that it will make water safety training DEFRA level 2 mandatory for all surveyors working within 2 meters of a riverbank. It's something for river modelers procuring river surveys to check individual surveyors' qualifications at the tender stage. Yeah, it's just a comment in to add to your.
Thank you for that comment. As I say, it's good. Thanks.
And then the last question I've got on here, you noted there was a large difference in the datum levels in Scotland, whilst there was a small difference in England and Wales.
Yeah.
Was there a comparison for Northern Ireland?
I think so, but I'm not really aware of it. It is something I have done a little bit of work in Ireland, and I was trying it itself in the Republic of Ireland. And yes, there are differences, but I'm not sure how large they are and how varied they are. And I'm afraid I'm not really very sure where to get that data either. The Ordnance Survey in GB is very well set up for having that information on their website. They have the report that I gave a link to and that comparison tool as well. What I would advise is go to OS Ireland, their website, and see whether they've got anything similar. So OS Ireland, because OSI and OS Ireland, Northern Ireland, work, in tandem with each other.
That's brilliant, thank you. Right, that's all the questions through. So just want to say again, thank you so much for coming to present this evening. It's a very engaging talk, and yes, a lot of very positive comments in the chat. So thank you very much for your time.
Thank you very much for having me. I've enjoyed it. Thank you.
Barbara, are there any other notices from HQ that you'd like to mention? Oh, Barbara, you're on mute.
Yeah, no, it's fine. I've been connecting links earlier on. So. But thank you again for a really interesting talk. And I think at the maximum we had was 239.
Oh, well.
That was really good.
Okay. And most of them stayed on to the end, I hope. Good. Thank you very much for having me. Okay.
No.
And I might offer to do it again in the future, or a variation.
I'll remember that one.
Yes. Okay. Thanks very much.
Thank you.
Brilliant. Thank you very much, everyone. Good night.
Bye.